Hello guys, welcome back to John's Workshop, and in this video an exciting parcel has arrived. So we're going to get stuck into that now. I know what's in it, and it's something that's going to be very useful hopefully. I don't really know what state it's in properly. It's an eBay purchase and there was only sort of 3 or 4 poor quality photographs to go off, so I'm taking a bit of a gamble, as you always do with eBay. So we'll get stuck into this now, and this video will be the sort of tear down of this and probably refurb of this unit, depending on what state it's in. So we'll get stuck in without further ado and get the boxing off it. All the excitement. These are they're helping. So this is a big heavy lump. So hopefully you guys can see what that is. So this is a rotary table for the mill. I've got a job. This video will probably go out after I've done an initial primary cleanup of this, just to use it for a job that I've got to do, and then once I've done that job, I'll tag the rest of this video together where we'll be taking this completely apart, cleaning it right up, and doing a full tear down and rebuild on it. So so yeah, this was it was on eBay. God, it's a big lump. Just bear with me while we get rid of the packaging. So this, I think, is a Bridgeport make. I think the description said there's no maker's name on it, but I recognise it from donkeys years ago, when I was sort of using these kind of things in sort of daily use, and I'm pretty sure this is a Bridgeport one. And what attracted me to this, it's a little bit big, if I'm honest, for my milling machine, but I think it will be okay. We need to make it work somehow. But I think the gaps where you put the T-nuts in and the sort of the bolts to hold it down, I think they're going to be too wide for my mill. But when I'm using it in this orientation, I don't think there's any reason, and I'll need to play with this, but I can't set it at a bit of an angle like that, which means I can then hopefully get into the T-slots. You know, it really doesn't matter what angle you start at, as long as you know where 0 is on the table itself. So first look at this, clamps undone. Yeah, it's pretty tight. There's some movement there, so I don't want to force it. It's got a graduation on here to break, like a vernier scale on the handle itself, and then obviously you've got your main degrees marked on the outside of the table. But as I say, what attracted me to this was, it can be used in this orientation as a standard rotary table, and unlike a lot of rotary tables you can buy of this size, you can stand it up vertically and use it in a vertical orientation, which basically turns it into a dividing head. Obviously I may need to make myself a tailstock of some sort, and over time I'll need to get myself some plates, make something up at this end for for the dividing element of it, but I'm sure that's not impossible to figure out. So I'll bring you back as we start to tear this thing down. As I said, what I'm going to do initially is just get this thing cleaned up roughly, get it moving around, get the base cleaned up and the top surface of the table, do some rudimentary checks on it, put it on the mill, and I've got a job to do on it immediately. And then once that job's done, this video will continue with basically the tear down and refurb and rebuild of this unit. So I'll bring you back when we're doing that piece. Right guys, we're going to start stripping this down now. So it's been used for a job, and those of you that have watched the Rotary Table adapter plate that I made for Derek will have seen this in use. One or two of you might have noticed that when you wind the handle, I don't know if you can see, but the shaft is obviously bent in here. You can see there's a bit of wibble wobble, for want of a better word. That's a proper engineering term, by the way. So that's obviously something that needs looking at. I don't know whether that was like that before the guy who I bought it off packaged it up, or whether it's been thumped on this end, while it's been in transit. The packaging looked not too bad when it turned up, to be honest, so it might have been like that from before, but I don't know. So that's something we need to look at. So basically we're going to strip this completely down to all its component parts, clean them all up, decide whether we need to remachine anything or whether we need to change anything about it. The way it's worked, I'm fairly pleased with it. I don't think there's a lot needed. We'll try and straighten this shaft out if we can, which will be interesting, and then we'll rebuild it all and put it back to a properly serviceable condition. So we're just going to start really taking bits and pieces off. So we'll start with the bits that are obvious and just generally work our way through various different bits and pieces of it. So we're going to need some Allen keys. So this is all Imperial screws. Which is interesting because I don't get to use those very often these days. Oh yes, there's some real thick rock hard grease that's in there. So it's obviously been packed with grease at some time. It's just gone absolutely rock hard. So that'd be why it's quite stiff to turn. Interestingly, it's got this unit on it that's like on an eccentric cam, and it's got two positions with a spring-loaded plunger. And basically what that does is takes the worm out of drive with the worm wheel. So this is now free to rotate, and then obviously it's quite stiff, but this will engage again back in with the worm wheel and then back into the position, and it's now back under drive with the handle. So we'll work out how all that comes apart. I think I'm going to need some rag and just try and clean some of this grease off to get an idea of what comes apart next. Yeah, I would imagine this is a threaded ring here that holds all of this in place. Yep, it is. I don't know whether there's a front or a back on this, but there's some numbers stamped. Every part's got a number stamped in it, which is interesting. That's got number 11 stamped on it. So I don't know whether these have been, yeah, that's got number 11 stamped on it as well. So I don't know whether these have been to kind of match fit. Yeah, that's got 11 on it as well. So everything's got 11 stamped on it. It could be the guy stamp who's built it potentially. I don't know. So this was built in India. Manufactured and built in India. So there you go, you can see the eccentric cam there now. That's obviously how that works. That unit's gripped on the outside of this so that when you turn it, it works like an eccentric to disengage the worm from the worm wheel. Now how does this come out? Oh, one thing I meant to say, by the way, the back of it there you can see has obviously got a piece missing, so this needs a thin piece of steel plate making up. There's obviously some screw holes where one's been at some point and somebody's taken it off and reinserted the three screws back into the holes. So as part of this rebuild I'm going to see if I can get a plasma cut ring or something. At best or at worst I'll have to try and make one myself out of some thin steel plate and drill the three holes, countersink them and fit these three screws back in, just to stop all the muck and rubbish getting into that bottom side there. Yeah, that will be part of the breakdown. So I'm just going to have a bit of a figure out and see how we think some of this stuff comes apart, and I will I'll bring you back when I've figured some of that out. Or shall we just take that off now? Some horrible grease on some of this. It probably looks like it's been on here for about 20 or 30 years, some of it. Yeah, that's going to be fun to remove, however that comes apart. I have no idea. Yeah, I'll bring you back when I've had a bit of a play with this and worked out which bits come off next. That's all the easy bits out of the way. I guess we can take this out. So that's the locking handle. Yeah, I'll bring you back, guys, when I've worked out which bits come off next. Right, I've just stuck this clamp piece back on because I've worked out that this is now an eccentric cam, and oh, that's a good fit. So that's the eccentric cam and the worm. Yeah, there's some real there's some really old-fashioned grease that's just absolutely rock solid as part of this. It's been really well made, actually. I don't know a lot about these Apex. It's an Indian. I think I mentioned it in my Rotary Table adapter plate video. It's an Indian manufactured rotary table. Oh, hello. We'll just drop that back in there for now so we know where it lives, whatever that piece does. Oh, that's the I don't know what that is. Oh, it's, yeah, that's alright. That's the thread. There's a threaded hole in there for that screw. So that's just the retention piece, just to hold. That's obviously to hold it axially to locate its position. So that's got that out. That's obviously the bent bit that we need to have a look at. There's actually not many components to one of these. I thought there'd be a lot more than this, if I'm honest. So I just need to get this gear wheel off now, the worm wheel, and pop the table off, and that's probably about it. There's probably only about half a dozen bits to the whole thing, which is surprising really. I was expecting a bit more to it than that. Now this is going to be the hardest bit to get off, I think. I've got no idea where we start with this, if I'm honest. That's the bung that was at the bottom, so that didn't have a very good thread in it. It was undersized, so I tapped that out to M12 when I was doing the rotary table adapter. So that just sits in the bottom there, which is ideal. Just drop a piece of studding into there. So I'll keep that, and that will go back in. Now interestingly, everything else is stamped 11. And these two pieces here are stamped 13, and interestingly they're stamped. They've obviously been stamped when they were assembled, because they've been stamped in the same place to obviously time the two pieces together by the looks of it. So we'll keep an eye on that when we refit. And it looks like there could be something in here. Don't know what that is. Maybe that's a dowel pin or something in there, like an anti-rotational pin or something, like a drive pin. Yeah, this bit's going to be fun. Getting this off. Yeah, I'll have a think about that. I'll bring you back when I've worked out how that's going to come apart. I'm not really sure at the minute. I'll bring you back when I've sorted something out. Alright guys, we've we've succeeded in getting that off. So how I've done that was I've had the thing stood up on its end, a gentle bit of heat, just using a propane torch, just to warm this, really, no more than that. And then with it stood up, started tapping the centre section, which is actually the table part, the spout on the back of the table, and I saw it starting to move down through the gear, and the table started moving forward out of the housing. And then once I'd got that moved sort of, I don't know, 5/8 of an inch, something like that, I then sat it this way round on the table, and I could see that this gear wheel was sort of loose-ish, and then I've just used my set of levers basically and just been going in each side of it and just giving it a gentle tweak until it's released. So there's the worm wheel, so that's that off. So now, all things being equal, the housing should lift off the table like that. And there's the table, and there's the dowel, the anti-rotational dowel that fits in between the worm wheel and this diameter at the back here. So that's it, I think. Okay, so that's it. So total piece part count: 1, 2, worm wheel 3, shaft 4, eccentric housing 5, handle 6, graduated wheel 7, locking mechanism 8. 8 pieces to the entire rotary table. That is a real surprise to me. I was expecting far more bits than that. So there's the housing itself. I don't know whether the camera's picking this up, but in the bore there's an oil groove. I don't know whether that's showing up. There's like an oil groove that's been machined through that central bore. and that's the locking mechanism that bites onto this diameter. What does that bite onto? Yeah, that just, so that's when you wind the lock in, it just pushes that forward and that just bites onto the outside of this diameter here by the looks of it, which is a bit of a strange design, but yeah, you can feel where it's been that's been rubbing. It's not the best idea, that's got a flat end on it biting onto a diameter, so you can definitely feel where that's been acting on there. There's a definite mark on there. Anyway, so that's it. We will commence cleaning up, so I'll do a piece at a time, get it cleaned up, bring you back and show you where we're at. There's the badge plate, apex. I think that's the only marking on it. Yeah, just that one mark. So yeah, that's that in bits fairly easily, really. Didn't put up too much of a fight, that. So we'll start the cleanup process and I'll bring you back piece by piece as we've cleaned it. I'll show you what I've used, how I've gone about it, and then I think the hardest part's going to be straightening this shaft out. I'm sure this has got a bend in it. We'll see. Has it got a centre in the other end? These are brilliant, by the way, for this sort of thing. Some dental tools. If you see a set of them and you're doing this kind of thing, get yourself a set, because they're absolutely ideal for picking grease and stuff. I mean, this grease is just, it's gone hard. So we've got a centre in that end. No, it's not really a centre in that end, unfortunately. That's a shame. We'll see if we can get this piece stripped down further. I'm assuming that just presses out. Yeah, it does, look. Again, there's oil grooves machined in to the bearing diameters. It's been well made. It's been really well made. It's just, that's a bit of an odd one. There's no centre in that end, which is a shame, because there's a centre in this end, and I was going to stick that between centres and put a clock on it and see if I could see if I can see where the bend is. There's definitely a bend in it. We might even, I don't know, might even put that up in the lathe, try and clock one of these bearing diameters in, and then put a centre in this end with a spot drill or something, just so that I can hold it up between centres properly and just do a bit of analysis on this and see if we can see where it's bent. Failing that, we'll try and set it up in V-blocks on the surface plate, and we'll locate on the two bearing diameters here on V-blocks or something and see if we can take some readings off it and with a clock, and just see if we can detect any bend in it. So yeah, I'll bring you back when we're doing some of that.